Welcome back for part 2 of oral and parental medications. In this session, we're probably going to focus more on calculations based on body weight and parental medications in liquid form. So let's take a look at this question, figure out what we're solving for. I am, again, a pattern creature of behavior, so we're going to start off with kind of doing some things. But before we really get too deep into it, I want to bring something to your attention. When you're doing anything that requires a weight conversion, my practice is do not convert the weight ahead of time, because what you're going to end up with is these really, really long numbers, and that's a lot to put into a calculator, which increases the error. Also, remember when you're converting weights, and if you're doing them independently before you start working out your problem, when you are going from pounds to kilograms, your number is going to get smaller. And when you're going from kilograms to pounds, your number is going to get larger. Okay, so let's take a look at our problem. We know that we are looking for milligrams administered per day. We have dilantin order of 15 milligrams per kilogram daily, and we know that the client weighs 80 kilograms. It's a lot of information, but it's the significant and relevant information that you need. So let's work out the problem on the next screen. All right, so we're solving for milligrams per day, weight of 80 kilograms, and here is our order. All right, so milligrams per day. Let's start with the order, okay, because that's going to be milligrams. That'll put it right on top. So we have 15 milligrams per kilogram, okay. We know that our client weighs 80 kilograms, okay. What we're left with, we're going to put our placeholder of day down here. So basically what you end up doing is just multiplying 15 times 80, and that gives us 1,200 milligrams per day as our final answer. Oh, so a lot to read right here. This is why I want you to look at what you need to solve. Use your highlighter, or if you're writing these on paper, or if you're using, questions from, a hard copy, highlight it, underline it, do what you need to do. So let's look at what we need. We have doxycycline 2 milligrams per pound daily for 10 days. Well, that 10 days is important, but I don't want you to see that number and put it into your calculation. That's just telling you how long you're going to give the medication. We have the supply as 50 milligrams per milliliter, and we are solving for milliliters, okay? Now, we know that the client weighs 90 pounds. And remember, our order says 2 milligrams per pound daily. And we also need to go to a whole number. So we'll set up our problem. We are solving for milliliters per day. Okay. And we know that the way that it is supplied, and here's why I'm starting with the supply. I want to get my milliliters on top, so I'm going to start with the supply first. We have 5 milliliters per 50 milligrams, okay? The order is 2 milligrams per pound, so we got to put that on top so they can cancel. And we know that the client weighs 90 pounds. Okay, so we don't need milligrams, we don't need pounds, we are left for milliliters, and that will be per day. So what we're going to do is we're going to stay across like we've been saying. We're going to take 5 times 2 times 90, and we are going to divide that by 50. And if you want to, you can go ahead and take a little break and pause and figure out your math. And once we do our math, we end up with 900 divided by 50. And when we do that, our final answer becomes 18 milliliters per day, already in a whole number. All right, so this problem also has a lot of information, and I want to highlight to you specific things that you're going to need, because this one's a little bit different. It's going to require an extra step for you as nurses. Let's highlight what's important. Physician orders Biaxin 7.5 milligrams. Let's highlight that really well. 7.5 milligrams per kilogram. Okay, that's orally every 12 hours. The strength or the supply is 250 milligrams per 5 milliliters. We're solving for how many milliliters are you going to give of this medication to a client who weighs 154 pounds. And then we want to round to the 10th placeholder. So that's a lot of stuff. So let's just take a minute and set up our problem so that we have everything in place. All right, so again, we are solving for milliliters per dose, okay? So let's start with something that has milliliters in it to kind of start setting up our problem. And that is going to be the strength. So we have 5 milliliters in 250 milligrams. We know that the order is 7.5 milligrams per kilogram, right? Now, we also know that for kilograms, when we need to convert to pounds, that in 1 kilogram, there's always 2.2 pounds, okay? So there's our conversion that we're going to need. And we know that the client weighs 154 pounds. And we are solving for dose. All right, so that is a lot. So this is why I've been kind of saying, take some time to set up your problem and then do a little cleanup. So do we need milliliters? Yes, we do. Do we need milligrams? No, because we're solving for milliliters, so we can get rid of that. Do we need kilograms? No, we do not. Do we need the pounds anymore? Nope. But we do need this dose. So now you're going to set up to do a little bit of math, staying what's top is on top and what's on bottom is on bottom. 5 multiplied by 7.5 multiplied by 154. That's a lot. Now, as you start moving into more complex compound problems, you're going to see this, especially when you get to titrations with critical medications. On the bottom, we have 250 multiplied by 2.2. See, this is why I do it this way, because I don't have to convert those pounds to kilograms. Now, if you went ahead and converted that ahead of time, you got a nice, pretty even number. It doesn't always work that way. So once we do our math, we end up with, let's see, 5,775 over 550, which leads us with 10.5 milliliters. And that is going to be the final answer because it is already in the 10th placeholder. All right, so for parenteral medications, these are medications that are injected into the body, typically IM or sub-Q. How they can come or the liquids can come in vials or ampules, and you'll start to get familiar with those. So that's just a little bit background, but our process is still going to be the same. We need to look at what we're solving for, and then we need to look at what's significant and relevant. For example, what is the order and what is the supply or availability, and then also paying attention to the rounding. So for this problem, we are going to solve for milliliters per dose. We have our order and our supply, and we know what we're going to end up with or what we need to do at the end. So let's just write out, and I keep writing this over and over again because this is my reminder to keep me on track when I set my problem up. We know that in the supply, in 1 milliliter, there is 100 micrograms of this medication. The provider has ordered 500 micrograms, and the client can get that up to 3 times every 8 hours, but that's not relevant because we are solving for dose. Once you do some math for that, and let me just go back here because I want you to see where we're going. This is where we end up with 5 milliliters, okay? And this does not require any additional rounding. It did say to the 10th place, and I bring that to your attention because a lot of times when you're doing milliliter per dose, it can go to the 10th, but this one worked out nice and easy. So let's take a look at this problem, kind of the same setup as before. Lots of information in the problem. Where are we going to head to? What are we solving for? Again, milliliters per dose. We have an order of 500 milligrams, and this one isn't subcutaneous, it's actually intramuscular, so I want you to kind of think about those abbreviations and start learning what those are meaning. And then this is going to be for 2 doses, but that's not what's important because we are solving for just the 1 dose, okay? And we also know that the medication is supplied in 213 milligrams per liter. And you say, well, we've been using a lot of, even numbers in these presentations, but I bring that one to you because you may see it that way. You always have to read the drug label in the order and see how it's supplied. So let's solve for milliliters per dose. We know that the order is 500 milligrams per dose. You can start with that one, or you can start with 213 milligrams per milliliter. I'm going to start with the milliliter. I know milliliter needs to go on top, so therefore the supply needs to go on the bottom. My order is 500 milligrams per dose. What we end up with, let's do that. After you start doing a lot of dosage problems, you kind of get in tune to the way you're doing it, but I just want to kind of bring it back that we've got our setup correct. And let's do some math. Now, when you do the math on this one, what you end up with is 2.347. But remember, we have to round to the 10th place. This is the 10th placeholder, okay? So we have to look at this number right next to it. 5 and higher, round up. 4 and lower, round down. That would make our final answer 2.3. So let me recorrect because I just realized what I said. 5 and higher, round up. So if this was a 5, that would go to 4. 4 and lower, you keep the number the same. As always, if you have any questions about this presentation, or need any assistance at all, please post your questions in the MDCC forum of your Blackboard course and have a wonderful day.